Earth's core may have trapped noble gases from ancient solar wind blasts. 4.5 billion years in the past, when the solar system was nonetheless forming, particles from our sun's photovoltaic wind mostly likely got caught up within the core of the Earth because it assembled from space rubble. The conclusion the scientists have drawn after analyzing an iron meteorite and discovering an extra of noble gases with isotope ratios per photovoltaic wind. Since iron meteorites are thought to be analogous to planetary core formation, that suggests similar abundances ought to have been included in Earth's core. The meteorite, named Washington County for the place it was found back in 1927, is a rare one. Of all the space rocks that fall to the Earth, roughly only 5% of the ones we retrieve are made of iron. Based on our understanding of planet formation, the iron meteorites are interpreted as cores of failed planets. Planets are thought to form when their stars are very young, possibly even at the same time as the star is still forming, and are orbited by swirling thick cloud of dust and gas. Dust and pebbles in this cloud start to collide and stick together, first electrostatically, then gravitationally, as the object grows more massive and can attract more material. These objects are basically planet seeds or planet simmels. As planet seeds grow, they become hot and bit molten, allowing the material to move around. Initially, the gases have been regarded as cosmogenic in origin, that's generated by interactions with galactic cosmic rays to which the iron meteorite was uncovered throughout the billions of years in space. Using noble fuel mass spectrometry, they have positively recognized that a few of an isotope ratios of neon and helium discovered within Washington County meteorite are far more per a photovoltaic wind relatively than cosmogenic origin. The measurements had to be extraordinarily accurate and precise to differentiate the solar signatures from the dominant cosmogenic noble gases and atmospheric contamination. For the Earth, this may offer a new solution for the problems associated with keeping different mantle regimes with distinct noble gas signatures. At the same time, this would imply a considerable previously neglected active role of Earth's core in mantle geochemistry and volatile geodynamics, which should be integrated into future studies. But the very fact these particles, like photovoltaic particles, is perhaps seeping out of the core and into the mantle is shocking and suggests we might have to issue a leaky core in future analysis and modeling, the researchers stated. If you are new to the channel, please subscribe my channel and wait for the next video.